Alright, so in this video, we are going to calculate this angle alpha that is string of length L makes with the vertical when it's in equilibrium in this electric field, of magnitude E. Okay, so it's in equilibrium, so right away I think you should know what concept we're going to have to use. Okay, and it's going to have to be the one due to the basically we're going to use net force equal to 0. So if I have the charged particle, let us draw all the forces on it. We have mg pointing down, we have T pointing at an angle alpha, and then we have QE pointing at some angle theta. And our goal is to figure out the angle alpha. Okay, so here's what we're going to do. Let us break things into components. Let's find the horizontal component of QE. That happens to be equal to QE times cosine theta. The vertical component of QE is going to be QE sine theta. On the other hand, let us also figure out now the components of T. The vertical component is T cosine alpha. The horizontal is T sine alpha. So now the problem is very easy. Let's balance out the forces. We know that T sine alpha is equal to QE cosine theta, and then we also know that T cosine theta, this is not cosine theta, this is alpha here. So we know that T cosine alpha plus QE sine theta equals mg. Okay, so now that we know this, we can essentially, in order to find the angle alpha, what we're going to do is just isolate T cosine alpha from the second equation. So this gives us T cosine alpha equals mg minus QE sine theta. Since theta, QE, all those things are given, we can do this. And now we can divide the first equation by the second, and we end up getting T sine alpha over T cosine alpha equals QE cosine theta over mg minus QE sine theta. Okay, so this gives us tangent of alpha equals all this QE cosine theta over mg minus QE sine theta, and this gives us alpha as tangent inverse of QE cosine theta mg minus QE sine theta. Perfect.